This will be a presentation on differential calculus, more specifically applying derivatives and optimization to real life. These calculus tools can be very helpful to businesses. In business, it is very important to consider the cost to make a product, the revenue of selling that product, the total profit, and the demand for that product. For a business to run smoothly and for profit to be maximized, so everything can be efficient, we use calculus. So some important units to know are that in this presentation, cost to produce X number of units will be C of X, revenue from selling X number of units will be R of X, profit will equal R of X minus C of X, also P of X for a shortened value, and then the price point or demand will be lowercase p, which is equal to this f of x equation given to us in the problem. In this example that I've provided, then the business has a monopoly on the product because competition would complicate the demand and the problem as a whole. So the given demand equation or price point is 100 minus 0.01x, and the cost is also given as 50x minus 10,000. And then the problem's asking us to find the value of x that maximizes the profit, the price to sell the product, and the total profit. So the first step is to find the revenue for this equation, so we can subtract it from the cost. And revenue is equal to the number of units times the price point being sold at, which is x times 100 minus 0.01x equals 100x minus 0.01x squared. And then step 2 is to get the cost, which is given to us in the equation. Example as 50x minus 10,000. And then as it's stated up there, then P of x is going to equal R of x minus C of x, or 100x minus 0.01x squared minus 50x minus 10,000, which simplifies down to minus 0.01x squared plus 50x minus 10,000. Then the next step is to graph the equation to get a little bit of a visual, and since we can see that there's a negative out front and only one squared variable, it's going to create a parabola facing downwards. And you can also find this by taking the second derivative of the equation. And then the next step is to find the first derivative of the P of x equation. So P prime of x is going to equal negative 0.02 x plus 50. And then to simplify that, then you can take out the negative 0.02, do x plus 2,500, minus 2,500, making a 0 at x equals 2,500, which, adding to the graph, the point right there, gives us the x value, optimized x value of 2,500, which satisfies the part of the problem that is asking us to find the x value, meaning we still have to find the y value of the equation, which is going to be the total profit and also the cost to sell the products at. Leading us to the next step of plugging in 2,500 to the profit equation, which is going to be P of x equaling 0.0 simplifies down to overall 52,800, which is going to be the amount of profit at the optimized place. So we so far know that the number of units to produce is 2,500, and the maximized profit is going to be $52,500. So now we just need to find the price point to sell the units at. It also gave us the Y value of 2,500. Okay, so the final step to find the price point is going to be plugging in that 2,500 value to the initial price equation. So P is going to equal 100 minus 0.01 of 2,500, which is going to end up simplifying down to 100 minus 25, or $75 per unit. So the price point is going to be $75, completing the required example. So this is just one example of how differential calculus can apply to real life. Jobs that could use this would be accountants, business analysts, and economists. They find themselves today turning into differential calculus for their daily work routines. Thank you.